First, a question. Who remembers this? Now, you didn't think you were going to come to a meetup in 2019 and see a slide about Coffeescript, did you? Sorry. Coffeescript was actually a really nice little language. Nice expressive syntax, very easy to read. And you would compile your Coffeescript files into JavaScript, right? Quite a nice, elegant syntax. If you look at a more involved example, doesn't matter what the code's doing, we're just looking at the difference here of sort of on a level of complexity. So Coffeescript was quite nice. JavaScript's got all those semicolons, curly braces, and Coffeescript came out of the Ruby community. At the time, the Ruby community, and to some extent they still do this, but they'll do absolutely anything in their power to avoid writing JavaScript. And I mean, absolutely anything. But Coffeescript was very good. It was very successful. You know, the rumor has it that many of the features that it pioneered in the language kind of influenced some of the things that we all use in our day-to-day work if you're writing ES6. So this is not to knock Coffeescript at all. But what's interesting though here is it's a language that you go from one source file and you compile it into another text format, in this case JavaScript. And that's because at the time JavaScript's the only thing that can run in the browser. So where is Coffeescript today? It's on the same list as things you probably shouldn't be learning in 2018, and I couldn't get one that said 2019. The point is it's a downward trend for languages like this. And why is that? Why didn't Coffeescript survive? I think it's two main reasons, and these are very personal opinions. First of all, when JavaScript is your compilation target, if you think about it, that means the very best you can do is the same as that target, right? So the very best you can get is feature parity. You may get some language features and some nice syntax things from the language that you're compiling from, but at the end of the day, if you're going into JavaScript, that's your baseline. And secondly, in the case of Coffeescript, I think it was just so influential and that it inspired JavaScript, and JavaScript just ended up getting good enough to the point where Coffeescript wasn't really relevant anymore. But the bigger point is, it's not really about Coffeescript, it's about this idea. If you have some empathy for those developers back in the day, imagine a web development shop. We've got a room full of very talented Ruby devs, and then you task them with building a front end. And if they've got the option to write it in something that looks like that language that they love and write every day, why would they invest in writing JavaScript? It wouldn't make sense. And the point here is that back in the day, if you could have run Ruby in the browser, then Coffeescript wouldn't have existed. And that's because modern browsers are limited to executing only JavaScript. Right? Wrong. It used to be the case. We're living in a very exciting time. Unbelievably exciting. Sorry, this isn't picking up very well if you see me doing that. We now have this thing with a great logo as well, called Webassembly. This is not just some replacement for compiling to JavaScript. Well, I guess it kind of is. Webassembly, and I'm going to turn around to read this bit with you. Abbreviated WASM is a binary instruction format for a stack-based virtual machine. WASM is designed as a portable target for blah, blah, blah. It's not very tangible to your day job, is it? Actually, this talk started off with a different plan, and I realized that what I could do instead is make something new and revolutionary that's coming down the pipeline. I could kind of make that tangible to you as developers, so that you can walk away from here knowing that you could literally go and write something in C++ or Rust and have it run in the browser today. And to do that, I want to start by simplifying that previous statement. The first thing to think about is that it's just the new binary compilation target. Coffeescript had to go into JavaScript because that's all you could do. But WebAssembly is here as a brand new virtual machine that sits at the side of JavaScript that can run with it. Binary just meaning that you write human readable code on one side and it gets compiled into bytecode on the other side. We don't want to dive into the technical details here. This is an overview. The second thing to think about when you're considering what WebAssembly is and when you go and tell your friends and colleagues about this is that it's an evolving standard. And that's a very important point, because if you go ahead and look at WebAssembly tonight and realize that you can't even change the text of a DOM node with it, it might seem extremely limiting. You might not understand the scope of it. It's an evolving standard because all the browser vendors got together and they agreed on a tiny, tiny MVP that they could actually ship. We'll get to that in a second. So it's extremely important that you realize that this is just the beginning of a giant process that's going to revolutionize everything. And the third thing that I want you to think about is that often WebAssembly applications can be the entire application, or you can, well, it's been explicitly designed to run alongside JavaScript, as I said before. So it's very, very useful for offloading some expensive computation to WebAssembly and still writing the rest of your app in JavaScript. So WebAssembly is not here to replace JavaScript in any way, shape or form. It may do to some extent because some people who like other languages may never write JavaScript again. But the goal of WebAssembly is definitely not to replace JavaScript. And here's the most amazing thing. You probably don't realize this. Well, some of you may, but you probably don't realize that literally all the browser vendors got together, and in every one of your phones, in every one of your pockets right now, you could be executing WebAssembly inside your browsers, inside your apps today. That's not an exaggeration. This is shipped. It's incredible that they did this, and it's deliberately because they went for such a tiny feature set that it happened. And now we have the amazing future to look forward to. So we're thankful to them. So now, circling back to the whole Ruby problem, can all languages compile to WebAssembly? Is it just the case that we're just going to take whatever you prefer to program in, if you're a backend developer doing PHP, for example, or are you just going to write PHP on the front end now? And unfortunately not. Yet. The nature of WebAssembly and the fact that it was shipped in such an MVP style means that only particular languages are well suited to it right now. That's changing. Like almost every week you see a new project come along. But there are certain languages, namely those that control their own memory, that are well suited to WebAssembly today. That's why you often see Rust strongly associated with WebAssembly, because it doesn't have a garbage collector. Again, not going to go into those details today, because as I said, I want to give you something where you can walk away from this and know that you can put Rust in the browser. So how does it work? The Rust logo there is just to mean some Rust code. You have to forgive me for the abstraction there, but it's just some Rust project. And you compile it, just like you would compile it for some operating system target. You just target WebAssembly instead. And this will give you a module. The tooling around Rust and WebAssembly also spits out a tiny bit of JavaScript. This is important. It's the JavaScript that knows how to load WebAssembly modules. But you don't want to have to write that by hand, and the tooling is there to automate it. So you have some Rust code, you compile it using a tool which I'll show in a second. It generates a .wasm file, which is your WebAssembly module, a binary format, and a tiny bit of JavaScript that's your glue code to make the whole thing work in the browser. So the JavaScript gets loaded into the browser, and in there, based on when you request it, it will go ahead and pull in the WebAssembly module. Let's keep going and make it more and more concrete. Eventually you'll see some code, I promise. There's two tools to do this. The first one's called WasmPack. You can probably imagine where they got the name from. WasmPack is like saying, take my Rust code and convert it into WebAssembly. But whilst you're doing it, give me that glue code that I need to make it work in the browser. But also, give me the TypeScript definitions whilst you're there. Because if I've exported a function from Rust that accepts a string, I want to make sure that in my JavaScript, that my IDE and my type system, if I'm using one like TypeScript, I want it to know about the contracts of my functions. That's WasmPack. And then to make it work in the browser, you'll use something like Webpack. Webpack, for those who don't know, I'm sure you do, is like saying, take a JavaScript entry point, trace all of its dependencies, and just give me a folder of production-ready assets. In this case, Webpack often gets a bad name for like these huge 200-line configs or more. Turns out Webpack has first-class support for WebAssembly. It's absolutely incredible. No configuration, no command line flags. If you import a WebAssembly module from a JavaScript file, Webpack will handle it. It's absolutely phenomenal. So I thought to myself, if I'm going to prove to everyone that WebAssembly is ready to be used from languages like Rust today, here's a challenge. If I can show you all the commands and the code that is required in a single slide to do it, I think that means that all of the tooling and the ecosystem is mature. It's ready to be used. Because if you think about it, it's absolutely incredible that you could even do what I'm talking about. A brand new shiny language like Rust and just run it in your web application with hardly any work. So let's go through it. You don't need to know what any of these tools are. It's very much, I'm just giving you an example of the fact that I can fit it on a slide, okay? So assuming you've got Rust installed, you would run this inside a project. Cargo new hello world, it will create a Rust project for you. You end up, and this thing doesn't, oh, it does a little bit. There you go. lib.rs, it will just scaffold out a tiny little Rust program for you. So the next bit is the actual Rust code. It's not too important what this does. The was and bind gen crate, they're called crates in Rust rather than modules or packages like they are in NPM. But the was and bind gen crate is by the Rust team, and it makes sure that values can be passed between the boundary of JavaScript and WebAssembly, and it also generates the code for loading and everything else. All we're doing here is on the very bottom function is we're exporting a function called greet that takes a name which is a string. That's all you need to know. The point is this is valid Rust, and the bit on the right there is the a little bit of extra code you need to add to your cargo.toml file. Again, not super important what it does, but we are writing valid Rust code that we're going to execute in the browser. So we're filling up our slide. What do we do next? All we've got is that source code so far. We run wasampack on it. Wasampack build hello world. This does all the magic. This just gives us a folder, and it's like a simplified thing. So pkg there, we've got the JavaScript file, we've got the WebAssembly file, we've even got a package.json file, which means you could actually publish this to NPM. You could publish a WebAssembly module. This is I haven't skipped any flags or anything. This is literally the command you run to get that. You've got a WebAssembly module and everything you need to run it. Pretty incredible. And don't know why I picked such a ghastly outline, but there you go. It's just that folder that it gives you. We're still on one slide. Next thing, to use that WebAssembly module, we still need to import it into our JavaScript. This is the thing. At the moment, you don't just write script source equals something.wasm. That's not how it works. You load your WebAssembly modules in through JavaScript. And it's not complicated. The dynamic import statement, which is coming in the next JavaScript version, hopefully, but is already supported by bundlers like Parcel and Webpack. You just point it at that directory that wasampack created for you. It will resolve with a promise. Sorry, it gives a promise, and when it resolves, you get hello world. Hello world there, probably shouldn't be named that, but hello world is the WebAssembly module and any functions that it exported for you. And then we call .greet with the string. And I'm sorry to say it's no more like, there isn't like a big reveal or anything afterwards. I've just imported a Rust project into my JavaScript and executed a function. Can you imagine? Now Rust is a low-level systems language, so you could be writing complicated algorithms, or you might just want to use its type safety, you might want to use some of its features, and you could easily bring it in and use it in your code. Just a script tag to your JavaScript file that Webpack generates for you, and away you go. We haven't even used up a slide. It's code that you can even read. I haven't even, made it so small. So just two final commands, which I won't cover in detail. You install the tools for Webpack and you run the dev server. And you get that. I know it's the most boring demo ever, like in terms of what you get from it. It's just a hello world, right? Hello Shane, in fact. But if you look, that's the output. But crucially, it's this. This is the bit about me giving you something tangible. I don't know how many of you have actually played with WebAssembly and loaded a binary module into the browser that's like native to all devices that can run, but this is how easy it is. There it is, module.wasm. By the way, if you do play with WebAssembly, almost all servers in the Node ecosystem don't give the right content type for .wasm files, by the way. It's like Express can't load a WASM file, for example. It gives it octet or something. It's the wrong MIME type, but you can solve it if you Google it. So, but the Webpack Dev Server, because it has, like I said, this excellent support for WebAssembly out of the box, Webpack Dev Server just spits it out, no problem. So I'm so excited about this. I can't believe that this is all I need to write in a completely different language and run it properly. Like, I'm not compiling to JavaScript. I'm running the code as it's meant to be. It's that simple. So you can imagine, because the tooling is now becoming mature, the ecosystem is becoming mature, there are frameworks and libraries coming out. This is one example called U, which is the whole talk was going to be about this. Basically, this has got it's like a mashup of Elm and React. This is like showing you the model updating and whatever else. Doesn't matter, you don't need to understand the code. But it's got like a component model, so it's basically like JSX in Rust, but it's all type safe. And if you think tree shaking is good in Webpack and JavaScript, well, if you have a language that's strongly typed like Rust, it becomes phenomenal. Another one's called Percy. This one's interesting because they're taking on the challenge of the isomorphic, if that's what we still call it nowadays, where like it needs to be able to server render, spit out a WebAssembly module on the front end, hydrate it when it loads in the browser so that it doesn't cause a repaint, etc., etc. So they're doing that with a component model as well. They're also doing like CSS in Rust. I've just called it that. Basically, the point here is that host and whatever will get replaced with a hash, like we do in React nowadays. Pretty cool stuff. It's all so exciting. And I thought I would end the talk just by showing you that, yeah, it's cool doing a hello world and it's cool looking at these things that probably aren't production ready yet, but they're getting there. But then it's more interesting to know that there's already things in production. Some of the standout things, not necessarily going to be that interesting to you guys, but it's the concept that's interesting. So Blazor, by like the Microsoft team behind C#, they're very, very interested in this idea because they've had numerous attempts at writing languages that compile into JavaScript, and now they just won't bother anymore because they'll just write their entire code base in C# and they'll compile parts of it to the browser, WebAssembly, run the backend in C# as normal, and away you go. Some really interesting talks about that, by the way, if you want to search on YouTube. This is my personal favorite. If anyone saw the Google Dev Summit or I.O., I can't remember, but Jake Archibald did a talk about this app that they built. It's absolutely phenomenal. What's cool about this one is it proves that WebAssembly is not there to replace JavaScript, is the fact that all of the UI here is just built in Preact, in just like tiny little component model in JavaScript. And then what they do is, because image compression algorithms are expensive and you don't want to write them in JavaScript, when you select one from the drop-down, it spawns off a web worker that pulls in a WebAssembly module, and it does the image compression and sends it back. Unbelievable stuff. You go and read the code base, it's not even complicated. The bit that compiles all the algorithms into WebAssembly, that's complicated. I don't understand any of that, but the general idea here is like, no, we don't need WebAssembly for the UI. We're already good JavaScript devs, but we do want it for something else. And the mashup of the two is incredible. Autocad have got their thing, although it didn't work when I tried it, funnily enough, for whatever reason. But the point is, they've got a legacy C, it's probably C++, I'm guessing. Anyone else might know. But they're just saying, well, obviously it'd be cool if you could just log in and do your AutoCAD stuff, so we're going to port that to WebAssembly. That's already out there in production running. A full AutoCAD application. Games, obviously. And I just want to finish with the 3 points from before, because I want you to go away from this and be excited about WebAssembly. And I just want you to understand it's just a that should say compilation target. I realised I was saying it wrong. It's just a compilation target. It's the new compilation target for languages. It's an evolving standard, so don't look at it now as, oh my god, it can't even change a class on an element on the page. And it can be the main application. It can run alongside JavaScript. That's probably the most exciting bit. And that's pretty much my talk. I'm Shane Osbourne, Shake Shane on GitHub. I work at WeAreJH, and I'm an instructor on Autocad if you want to learn more about JavaScript. Thank you.